So what we're going to do today is we're going to see how we can find and break breach paths into cloud environments. And also we're going to learn how the breach paths can be detected using infrastructure as code. And not only that, we're going to have live demos available for the live attacks, both for detecting and breaking into the breach paths. So my name is Moolchandani, CISO and CTO at Accurics. I'm accompanied by Harkirat Bhardwaj, who is my fellow security researcher here, and we're going to take you on this journey together. So the agenda, first we're going to see how we can create vulnerable AWS environments using infrastructure as code and a Jenkins pipeline. We're going to talk about a very cool open source project, which contains really good vulnerable infrastructure as code templates that we will be using. Second, we're going to look into quickly how threat modeling exercises can be conducted on infrastructure as code, and we can build a threat model of the cloud environments just by analyzing infrastructure as code. Then we will perform a live breach on a vulnerable AWS cloud environment, and then we will see how we can detect these breach paths using open source tools and infrastructure as code. And we'll also see how we can break the kill chain using open source tools. So hoping that everybody is ready to go on a ride. Let's see. So what we're going to do in terms of our deployment process. So we have some bunch of Terraform scripts today, which are vulnerable in nature. We're going to use them, push them in GitHub, set up a pipeline, and then we're going to deploy a vulnerable cloud environment, which is going to look something like this. So in this environment, we're going to have a VPC, a couple of subnets. We're going to have a couple of EC2 instances. One EC2 instance, is going to be exposed to internet. The other one is not going to be exposed. But we're going to purposely also leave a vulnerable application deployed in the EC2 instance, apart from the other misconfigurations that we're going to leave as vulnerables. So I'm going to go through those misconfigurations as well as the application that we're going to package and deploy using infrastructure as code. It's going to be very interesting. So let me quickly show you the code before I go there. So we have an open source project called as KaiMonkey. KaiMonkey contains a number of different vulnerable Terraform files, which we can use. We're going to be using a scenario-based deployment today. So we have a scenario today, which we're going to look into. If you go into KaiMonkey Terraform folder, AWS, you're going to see scenarios SSRF IAM breach. So this is a folder which contains Terraform files, which we are going to use today for deploying the vulnerable application as well as the vulnerable environment with lots of misconfigurations and some vulnerabilities. Now, if you look into the provisioner type section here, we do have a vulnerable application that we are packaging, and we're going to be deploying it in an EC2 instance. So this is part of the resource type AWS instance. It's a web application. We're going to package it there, right? And the application is also available within the same bundle. It's bundled in a zip file here. This is a simple web application which has a SSRF vulnerability. We'll see how those exploitations will work, right? So before we go there and show you how the deployment will work, let's quickly talk about at high level some threat modeling, some threat modeling exercises as well as some threat modeling techniques that we will be conducting today. So what we will be actually looking into, this is a threat model that I'm going to show you at the beginning of our talk, and you will see how we actually ended up creating this whole threat model by analyzing ISE in the next slides. So we're going to be seeing a EC2 instance, which is going to be exposed to internet, of course, because of a misconfiguration. And then we're going to be also seeing that the EC2 instance is going to have another misconfiguration. It will have your IMDS, which is Instance Metadata Service version V1 enabled. Now, for all of you, security nerds out there, you guys know it, that you cannot exploit a SSRF vulnerability the way we're going to be exploiting it today. We're going to show you that if you don't have Instance Metadata Service version V1 enabled, because the idea is that we actually are going to steal the access token and the secret access key by actually using the magic IP, which is available on your Amazon. So I'm going to show you that whole attack, but that is possible only if you have IMDS version V1 enabled. So we're going to be doing reconnaissance because your EC2 is exposed to internet. You have a vulnerable application deployed there, And then we're going to start weaponizing these misconfigurations, such as IMDS version v1. Next, of course, because of the SSRF, we'll be able to do the delivery of our attack. And we will also see that on purpose, we have left another misconfiguration, which is a overly permissive IAM role, which provides excessive EC2 accesses to the secret keys that, or the other way, to the IAM role which is attached to the EC2 instance has excessive and overly permissive IAM role. Now, the way we're going to be exploiting that, we're going to be using this role to perform further enumeration in the cloud environment, and we're going to be able to gather more information about other EC2 instances which are located in the same environment. And then we're going to be doing lateral movement. So we're going to be understanding if we can find another EC2 instance in the same environment, which has some weakness. We'll be exploiting that weakness. In fact, what we will be doing is we will be installing a backdoor into another VPC, into another EC2, which is located in different subnet. But the way we will be doing that is we will be injecting the backdoor actually into user data. Now, all of you know that there's a configuration setting available in AWS. You can inject a shell script into user data, base64, which basically gets executed when you are booting up the EC2 instance. So we're going to see how we're going to actually install the command and control backdoor also there. And then further, we can take more actions. We can disable CloudTrail logs. We can do many other things after that. So that's how the entire kill chain will proceed and the attack phases will proceed. We're going to see all of this in the live attack as well today, but this is how the threat model looks like. Now, how did we created this threat model? Like, how did we ended up? What about the defense side of things? How can we actually create this threat model just by analyzing infrastructure as code? So let's look into some of the potential sources first. Why such problems, such misconfigurations actually get introduced into your cloud environments. Number one, well, you might have left misconfigurations in your runtime due to lack of cyber hygiene. Like, there's lack of scanning processes and also lack of understanding about the security in general within the DevOps team that can lead these misconfigurations. Also, the DevOps teams really have to move at hyper pace. They don't have time, available to do a lot of things in security. Sometimes the velocity of change introduce these issues as well. Number two, accidental misconfigurations that are left, inadvertent misconfigurations that are left in infrastructure as code. Also, lack of security testing at the design time. When you are designing your infrastructure as code and you don't do testing, a lot of times these misconfigurations will actually creep into your live environment. Next is you might have created your runtime environment really secure and you would have started with the right compliance state, but then drifts can be caused because of the changes that are happening continuously on your runtime environment, and they could leave the misconfigurations as well. So drifts is another reason that we've been observing. And lastly, lack of collaboration and context between the application security team and infrastructure security team can also leave breach paths, because as we're going to show you in the examples today, we have an application which is vulnerable, but then it gets packaged into the infrastructure as code and then it gets deployed. And of course, there's not much visibility available to both infrastructure team as well as application security teams to collaborate to understand that actually a vulnerability in an application can open up such a huge breach path, right? We're going to see some of those things, how we can actually address them. So let's take a look quickly how the accidental misconfigurations are left in an ISC. As an example, we have this Terraform code. You will notice that there's an EC2 instance which has been defined here. This has been open. This has been left wide open to internet because the security group is kind of misconfigured, right? That's how the misconfigurations creep in. Next, if your EC2 instance is wide open to internet and if it is attached to a public subnet, well, either you need this legitimately or you might, do an accidental misconfiguration, and that is again something that can open up the breach scenario. Now, of course, finding these openings is not an easy thing, but you have to correlate a lot of stuff. Like, for example, find out if you have an EC2 instance which is attached to a subnet, then the subnet has a route table, and if the route table has a single route attached to it, which has an internet gateway, on it, then that's when you'll be able to determine that, yeah, there is really an opening available here, right? Next, such as this one. instance with IMDS version v1 enabled. Now v2 is available. Everybody should use that, but sometimes accidentally you can leave it, with IMDS v1, and IMDS v1 actually will allow the magic IP to go ahead and be accessed, and then you can download the credentials such as secret access keys and access tokens. Next, you could end up packaging a vulnerable application. So at the time of packaging your applications in infrastructure as code and preparing for deployment, if you don't have visibility into the security status of the application, that can again introduce the breach paths. And we have seen way too many cloud breaches in last 2 years because of this one single misconfiguration scenario where the application, context from security point of view was not available to infrastructure teams, and they ended up deploying vulnerable applications. So even though this application that we're trying to deploy here might have been scanned by a static code analysis tool, and the vulnerability information probably is present with the static code analysis tool, but it's not available to the infrastructure security teams to be able to correlate and understand that what kind of impact it may cause. That's another reason why it's important to understand the impact of application level vulnerabilities on infrastructure. And then lastly, we could have overly permissive EC2 instances where, there are IAM roles attached to it, and the role actually ends up, providing more permissions such as, EC2 star. So it can actually go ahead and now, it allows the role to actually access other EC2 instances as well. So if your one EC2 gets compromised, there's an opening available for the attacker to access the other ones as well, right? Likewise, you could leave EC2 instances, with admin privileges. And those privileges are, again, if you're configuring using infrastructure as code to configure your IAM roles, then you have to be very careful, because your infrastructure as code can actually provide you an opportunity to detect these problems early, but then it can also kind of slip past your DevOps pipeline and can actually have EC2 instances with overly permissive roles and privileges, right? Okay, let's do a quick demo of this attack, and then we will also understand that, how exactly we're gonna walk through the entire attack, and then we're gonna see how we can defend against it, right? Let me quickly pause my share before I reshare it with my attack environment. So, just a moment. Go.
And also, I think in the beginning you were sharing your video, and now it's not shared again. So I don't know if that was intentional, but we can't see you. None of that. We can see your screen. We can't see your video.
All right, tell me if you guys can see me now.
Yeah.
Okay. All right. So let me go through the demo now. All right. So what we're going to do is we're going to pick up the vulnerable modules that we have in KaiMonkey, and we're going to package KaiMonkey. We're going to basically create a Jenkins file that we're going to we're going to use to deploy this application on a cloud environment. So you can see in the main.tf, you can see we are packaging a lot of different misconfigurations which are vulnerable in nature. And then also we are going to package this application also in the Terraform file. So we're going to highlight some misconfigurations first. There's another misconfiguration that we just highlighted, which is on the IAM role. And then we are going and also checking out if we are packaging a vulnerable application here. So you can see the provisioner. We are actually adding this misconfiguration, which is basically adding an application which has a vulnerability. So next, we are going to build a vulnerable environment using Jenkins. So we're going ahead and modifying our Jenkins file, and we're basically going to make sure that we are doing a Terraform show as well. We're going to deploy, and then we're going to run the Terraform apply process. And then at the end, we're going to see that we will receive the public IP of the EC2 instances which are created. We're ready to fire up the build. So we've created the build environment here, and we're going to basically now fire up the build process. As soon as the environment is going to be ready, we will jump right into our first attack activity, which is reconnaissance. So, which is waiting for the vulnerable environment to finish. And if you see the logs, the Terraform apply has worked. And we are about to see a live environment on one of the AWS VPCs that we are using. And we're going to basically now get the public DNS, and we're going to jump right into the vulnerable application using the DNS URL. And when we do that, this is the first activity that we're going to perform. We're going to see, we can do reconnaissance, of course, because not just because EC2 is exposed to internet, but also because there is a weakness available, which is on the application, which is being hosted on that EC2 instance. And we see that we did get an error. Now, this error is a legitimate vulnerability. Basically, it's coming in because of the vulnerability. The SSRF vulnerability exists at one of the variables, and we are going to misuse that. What we did here was now we invoked the magic IP, we went into the metadata, and we are seeding the security credentials of that EC2 instance. So we're going to pick up the access key ID, and we're going to also pick up the secret access key and the token as well. So once we are able to pick this up, now the attackers can actually do the next level of attack. So we're going to use this framework called as Parkour. In Parkour, we will be setting up these keys that we have just stolen. And once we set up the keys, we are going to be able to do further activities such as enumeration, and we're going to go further in deep into the environment. So we're going to use set keys option available in Parkour framework. We're ready to set the keys that we have just stolen. So the attacker was able to steal the keys. Now we're going to just provide the credentials, and right after that we will start our further activity. So this is where we are stealing the keys, and we've just populated them in Parkour, and we are going to basically now set up the system. And we're also setting up the region, by the way, here, so that we know that what region we have to focus upon. And now we're going to check. So we've set the keys. We're going to check if the EC2 instance profile has what kind of permissions. So we are conducting the enumeration process here, and we discovered that the EC2 instance profile has got permissions available to actually brute force the IAM permissions, which are available elsewhere in the environment. So we're going to run the IAM brute force permission module within Parkour, and then we're going to see what we discover out of here. So what we discover is that there are a number of items available in terms of EC2 permissions. So there are a host of EC2 permissions which are available for us to play with. Remember, we are inside the first EC2 instance that not the inside, but we have stolen those keys. And now with the help of those keys, we are going to do more enumeration. We understood that the keys that we had stolen had permissions to do enumeration on EC2 or had EC2 permissions. So we are running a EC2 enum command on Parkour, which is going to do further enumeration on EC2 instances. We discovered there are many other EC2 instances available in this org. And now we are looking for some EC2 instance which has, say, admin privilege available. Okay, we found one. This is an EC2 instance which has an attached profile, which is a privileged instance profile. Fair enough. So we're going to steal the instance ID of it. And then we are going to make an attempt to see, with the help of the keys that we have stolen, can we actually inject a backdoor in this EC2 instance, which is running an admin profile. So we're going to see if we can do a EC2 startup shell. Parkour has a really nice module here. So see that we have, we're first kind of trying to pick up a script here. This script is basically going to be connecting to ngrok. We have an ngrok running in one particular tab. And then what we're going to do is we're going to inject a backdoor, basically a simple reverse shell connect script. So we are trying to make an attempt here with the help of Parkour on the EC2 instance ID that we have stolen. This is the script.sh, which contains a reverse shell, and the instance ID is being passed now. So we are passing the instance ID. Let's see on this particular instance, which is the second one, can we do the delivery and exploitation? So this is just a misconfiguration that we are, exploiting here. And we see on the right-hand side, we have our netcat running. So let's see if we can receive a reverse shell on the netcat. And you can see on the overlay that we did receive a reverse shell. Now we actually got a root shell on the second EC2 instance. So the attacker did manage to do a lateral movement because of the misconfigurations, right? So now,
sorry, Om, to interrupt. We have some feedback from the audience that the screen is really blurry. Is there any other way that you can present it? They're saying that they can't really see what the code is.
sure. Let me optimize, my screen.
Thank you.
You should have that any moment now. Okay. Hopefully this is a little bit better. So what we did was, we took over the second EC2 instance with the help of a misconfiguration. We injected the backdoor there. And with this backdoor, now we are inside the other EC2 instance on the right-hand side. We took the reverse shell, and now we're trying to steal more tokens out of it. So on the second EC2 instance, we have done the enumeration. We have found more tokens and secret access keys there, which we're going to copy, and we're going to do further enumeration there on the second EC2 instance. So we can go more further now. Now that we've taken admin credentials on the second EC2 instance, we can very easily go ahead and perform other capabilities as well. So with these capabilities, what are some of the things that we can actually perform and do? So let me quickly go ahead and pull up some of the other items. Give me a second. Go. Coming up. Okay, just a quick recap on what we did so far. So we used a few attack tools. So we took the initial access to the cloud environment, exploiting the SSRF vulnerability and taking advantage of IMDS v1. And we used the local address, which is otherwise also called as a magic IP. And we did the stealing of the keys. Once we did the AWS access and secret keys infiltration, we were able to enumerate further the AWS environment, and we found that it had the permissions to do further probing on the EC2 instance. So we used the tool as Paku tool to discover instance with the admin permission, and then we did the privilege escalation by actually deploying a backdoor in the user data misconfiguration within the EC2, and then we took the reverse shell. Now that we've done that, how do we go about detecting this breach path? How do we protect ourselves against it, right? So first, of course, we can enable the WAF, we can disable IMDS, use principle of least privileges and all of that, but can we use scanning on infrastructure as code to actually detect these breach paths, right? I think we can. Let me show you how we can do all of that. So what we can do is we can use open source tool called as Terrascan. In the open source tool Terrascan, we can perform full scanning of infrastructure as code. Terrascan uses OPA, Open Policy Agent. It's powered by the full power of Go, and OPA is available. It can evaluate against several different policies. These policies are mapped to different breach scenarios, and then we can basically detect these breach paths. If we can run them, we can run the Terrascan locally. We can run Terrascan by integrating it with the CI/CD pipeline. We can see both examples today, and we'll see how the breach path can be detected using Terrascan. So just give me a second. I'm going to optimize again my go. And I'm going to resume. So what we're going to do is we basically are going to look into our options to use Terrascan. So on KaiMonkey code. So when I run Terrascan here, first is we can detect all the reconnaissance capabilities using different reconnaissance policies that we have. So this is going to be able to highlight that the reconnaissance capabilities are available in your vulnerable infrastructure as code. You can detect them really early in the development lifecycle itself. Next, we also have policies in Terrascan, which can actually detect if you have delivery and weaponizations capabilities available also in your environment. And when you're running them locally, you will be able to detect not only just the policy violation, but also you can detect what kind of capabilities they're introducing from attackers' perspective. Likewise, in this particular example, where I'm highlighting that you have an instance which is launched with high privileges, you can actually launch it with low privileges. So this allows you to actually do more, installation as well as command and control kind of capabilities. You can use Terrascan to detect most of these breach paths. But at the same time, you can run Terrascan in your pipeline to make sure that before you are provisioning your cloud environments using infrastructure as code, you should be able to scan it. So we are adding a stage here, which is going to do a Terrascan scanning, and it's going to happen before the Terraform plan happens on your pipeline. So we're going to just set up the Jenkins file really quick, and we're going to go into the pipeline and we're going to run the scan on the pipeline itself. So pipeline scan is coming up in a second. So we have modified our Jenkins uh, configuration now, and we're going to reissue the pipeline scan. Once the pipeline scan finishes or the pipeline is ready to provision, if there are issues reported by Terrascan, you will be able to view those issues right within the Jenkins itself, and you will be able to actually see if you have breach paths available in your possible cloud environment that you are building. So since we are performing the scan failed and it found some high issues, and you can see that there were actually policy violations detected within the pipeline itself. So you can integrate Terrascan with pipeline, scan your code, detect these breach paths, and then you will be able to also understand what are the security implications by assessing your infrastructure as code. So some of these capabilities are already baked into Terrascan. You can use the open source project to actually scan most of your Terrascan code, your Terraform code. You can also scan Helm charts, customize, and few other types of infrastructure as code as well. Terrascan comes with a host of policies. You can try it and see how it works. Next, I have a couple of slides to go through, and I'm going to quickly share those slides. Switching my view here. So what we saw today is that how we can actually get into a vulnerable environment by actually taking advantage of the vulnerabilities as well as misconfigurations. We can perform the entire breach path, live hacking on a live AWS environment, but all of those breach scenarios and attack patterns can be actually detected by doing infrastructure as code scanning. We can detect the reconnaissance by using policy as code, such as tools such as Terrascan can provide that capability. We can also detect exploitation, delivery, and weaponization capabilities if they're available within the infrastructure as code. Likewise, advanced capabilities are also detectable, like, can you install, can you do command and control? For example, if there's a permission available to modify your user data, you can do installation absolutely of a backdoor. And then you can also check if you have other policies available or policy violations available that can allow you to disable your cloud trail and other kind of post exploitation capabilities that the attackers would want. So that's it from our end today. Hope you enjoyed our demo and how the attack works, and also how you can detect breach paths using infrastructure as code scanning.